Namaskar. So now let's have a look about the capacitor and capacitance, how we can calculate, what are the basic concept behind it. So let's begin and have a look on the properties. So you can say the capacitor is the system of two conductors separated by an insulator. So you can assume, let's say this is your conductor 1, and let's say there is a another conductor 2, right? And if they are separated with a finite distance, and in between there is a dielectric medium, vacuum or whatever here, but it will form a capacitance. And let's say these two charge conductors having charge Q1 and Q2. In fact, in general, the charges on the two conductors are Q and minus Q, and then this such type of system are called capacitor, and they have the property that they can store charge between that. So we'll see that how they store charge and what are the physical significance of that. And let's say if the conductor is having a potential V1 V2, and then their potential difference would be V1 minus V2. So what would it mean? It means that bringing a charge from conductor 2 to conductor 1, if you are bringing a charge Q, then you have to do power on a unit positive charge, then work would be done, and that would be stored in energy. So in such cases it would be proportional to the electric field, right? So if this the potential difference is there, then there is electric field in between, and that would be uniform, provided it satisfies a certain condition. That will again discuss what condition is that. But first of all, to see here that potential difference V is proportional to the charge Q, and there we utilize the proportionality constant, we call it C, and C is equal to QV. So this implies the capacitance definition, where it is C is equal to Q by V, and this makes that C the capacitance as it is now charge and voltage independent, and it only depends upon the size of the conductor and distance between them and area of the conductor, and also the dielectric medium. So that we would see in our next lecture, that what are the dependency on that. But these are the factors, and here the definition comes, where the capacitance is given by C is equal to Q by V. So here we have said that the two conductors. So even the second conductor you can imagine at infinite. So any metal conductor, and between it can also be considered as the capacitor. But of course, depending upon the distances between them and all, the capacitance value vary, and that again we will discuss in a later part. Okay, so till now what we understood is that capacitance is the proportionality constant between charge and voltage between the two plots, and where Q is that charge in one of the metal conductor of the capacitor. And the unit of capacitance is given by SI unit. It is given by farad, right? So if 1 farad would mean is that 1 coulomb per volt, and this is actually is a very big amount, 1 farad, just like we discussed in the first lecture, that 1 coulomb is a very big charge, and then we utilize it in microcoulomb and picocoulomb. Similarly, here in farad we utilize 1 microfarad is equal to 10 power 6 minus 6 farad, or 1 picofarad is equal to 10 power minus 12 farad. So some kind of this kind of level we utilize at different levels, and also mostly use 1 farad is equal to 10 power minus 9 farad. So these are the metric conversions, and these are the order we typically see. And again, once we discuss about that dependency of the capacitance on the dimensions, so we will see that what 1 farad, how big it is, and then you will have some relative understanding about it. And also the important other point about capacitance, that what we represent in the capacitance, how we represent it. So it typically in case of fixed capacitance, we utilize the symbol like this, and if it is a variable capacitance, so then we utilize this symbol, where we just provide this variable symbol to it. Also, the good point here, as you see that as you can see from our definition, Q C is equal to Q by V. So it means that this for a given capacitor, it can hold a very large amount of given very large amount. A very large capacitor can hold a very large amount of charge at a very low potential, right? Because it is inversely proportional to V. So it would mean that no, you can so it have a very good practical significance. For example, a very strong electric field can ionize the charges, and it can create a spark which will further leak down the capacitor. It means then it will compensate. For example, the maximum electric field which a dielectric can withstand is called dielectric strength. So for example, you take illustrated dielectric strength. So that is the maximum electric field that a dielectric medium can withstand without breakdown, and for air it is somewhere 3 into 10 power 10 power 6 volt per meter, right? So this is for air, and it would mean that if you have a capacitor and between them if there is a 1 centimeter distance, so then you can the voltage would be what? It would be so what voltage difference it can hold? So it would be 3 into the power 6 divided by 100 centimeters. So per centimeter, 3 into 10 power 4 volt per centimeter, right? So it means that if the two capacitors plates are separated by a distance of 1 centimeter, then the maximum potential it can difference it can have is that 3 into 10 power 4 volt per centimeter, the electric field. So it means the difference between for this kind of capacitor with the potential difference is of the order of 10 power 24, then or above that. So we may have a breakdown occurrence, and that would be just charge the atmosphere here, and then that can compensate the charge within it. So it means then the capacitance of this would decrease, and in other words you can say that the capacitor would leak due to the reduction in the insulating power of the dielectrics. So this is another important point about the dielectric instance importance, and of course depending upon the dielectric which you are going to use in between that plates, the capacitance is going to vary and their strength is going to vary. So this is about the capacitor and capacitance and how to calculate it and what are the units conversion if for the different orders of units of the capacitor. So important learning to take from here is that the capacitance definition is given by that for per unit voltage difference, the charge stores in a between two conductors with a given dielectric medium is called capacitance. And two important points, that dielectric strength which is of the order of 10 power 6 volt per meter. It means that the threshold voltage between the two plates between in the capacitor V is equal to of the order of 10 power 4 volt for 1 centimeter distance of the two conductor plates if it is there. So these are the threshold points, and if it is beyond this threshold, then you may have the electric field between that, then you may have a problem of leakage of the capacitor, and it may not hold longer because it will create a discharge or a spark within, and the air will become conducting or the dielectric medium will become conducting, which will not hold the charge here on the plates because they will just dissipate. Okay, so this is all about capacitor and capacitance, and we'll further see that about what is the parallel plate capacitor. We'll utilize that concept which we studied here, and in the case of parallel application, how we can calculate the capacitance and what are the dependency on the different electric medium and the size or dimension of the capacitor. See you there. Thank you.